Today, we're going to pull back the curtain on the hardware that's literally the backbone of our digital lives: high-performance network switches. Yeah, these are the unsung heroes making sure everything just works, and we're going to dig into exactly how they do it.
All right, so here's the game plan. We'll start with the big problem everyone's facing with their networks. Then, we'll check out some real-world solutions based on our source material and wrap it all up by decoding the tech jargon that makes this stuff tick. Sound good? Let's go.
Okay, first things first, let's talk about the incredible strain our networks are under these days. I mean, it's basically digital gridlock out there, and the traffic just keeps getting heavier.
You know the feeling, right? You're paying for super fast internet, but your video call is still lagging, or a download is just crawling. So what gives? Well, a lot of the time, the bottleneck isn't your connection to the internet. Nope, it's happening inside the network, in your office, across campus, or even in the giant data centers running all your apps.
Think about it. Every video meeting, every file you save to the cloud, every stream, it's like another car getting onto a highway that was designed decades ago. It's just not built for this kind of rush hour, so you get these massive, unprecedented digital traffic jams. And that means we need something way smarter and more powerful to direct all that traffic.
So how do you solve a problem like digital gridlock? Well, that brings us to the solution. We're going to use the AirLive products from our source as a kind of case study to see how these, let's call them digital traffic controllers, get the job done.
Right, so the source material basically splits these solutions into two big buckets, and they're for totally different jobs. You've got the enterprise campus core switches. Think of these as the absolute heavyweights, the beasts built for giant data centers. And then you have the more flexible multiport fiber switches. These are the workhorses for connecting everything from different office buildings to servers for small and medium-sized companies.
All right, let's start with the big guns, the enterprise core switches. I'm talking about hardware built for the most intense, demanding environments you can think of. Places where raw performance isn't just important, it's everything.
What this means, in plain English, is you get zero packet loss, super low latency, and what's called non-blocking performance. Basically, data just flows. It's instantaneous, it's perfect, nothing gets dropped, nothing gets delayed. And that is absolutely crucial for things like financial trading, big data research, or massive cloud platforms where even a millisecond of lag can cost a fortune.
And this is where it gets really cool, because you can see it's not a one-size-fits-all game. You might have one switch that's just loaded with, say, 32 massive 100 gig fiber ports, perfect for the heart of a data center. But then another model might mix in a bunch of high-speed copper ports for connecting hundreds of individual workstations. It's all about picking the exact right tool for the job.
But look, all that speed is worthless if the system isn't reliable, right? I mean, if the network goes down, the entire business grinds to a halt. So these things are engineered with one single obsessive goal. They cannot fail, ever.
And here's how they do it. We're talking redundant, hot-swappable power supplies. That means if one dies, another one is already running. And you just swap out the bad one without skipping a beat. You've got these clever protocols like MLAG and VRRP for instant network and router failover. Even the cooling has smart fan tech. It is literally a system of backups for your backups.
Okay, but not everyone is running a Google-sized data center, right? So let's shift gears and look at that other category, the versatile multiport fiber switches. These are all about secure, efficient, and most importantly, flexible connections for a whole range of other businesses.
What are we talking about here? Well, it could be for linking servers that are sitting right next to each other, or it could be for connecting two different buildings across campus with a blazing fast fiber link. Or maybe it's just making sure that the big AV presentation in the boardroom runs without a single glitch. It's that kind of stuff.
And this table shows a really important distinction, the management level. You've got your powerful Layer 3 or L3 switches. These are for the pros. They give network engineers super granular control over how traffic is routed between different networks. But then you also have what are called web-smart L2 switches. These are much simpler, more plug-and-play, perfect for smaller outfits that just need fast, reliable connections without needing a PhD in networking to set it up.
Okay, so we've been throwing a few acronyms around. MLAG, EVPN VXLAN, VRRP. Sounds like alphabet soup, I know. But these technologies are the secret sauce behind all this performance and reliability. So let's take a second and actually break down what they mean in simple terms.
First up, MLAG.
The analogy here is two network brains working as one, and that's pretty spot on. It lets two completely separate switches act like a single, ultra-resilient unit. Why does that matter? Because if one of those switches dies, the other one takes over instantly, no interruption. And when downtime can cost a company thousands of dollars a minute, that kind of seamless failover isn't a nice-to-have, it's a must-have.
Next, we've got EVPN VXLAN. The analogy is a VIP lane on a highway, and it's perfect for what it does. This tech is absolutely critical for modern data centers, where lots of different customers are all sharing the same physical hardware. It creates these secure, private tunnels for each customer's data. So think about a cloud provider. They can use this to make sure my data and your data never, ever cross paths, even if we're on the same server. It's all about multi-tenant security and isolation.
And last but not least, VRRP. This one is a lot like MLAG, but instead of being for switches, it's for routers, the gadgets that direct traffic between different networks, like from your office out to the internet. It's the same idea. Have a backup router on hot standby. If the main one fails, the backup takes over so fast that nobody in the office even notices their internet blinked.
So, when you put it all together, what's the big takeaway? Well, it's that there's no such thing as the single best switch. It's all about matching these incredibly powerful features to a very specific need. Are you building a data center or connecting two offices? The answer to that question changes everything.
And that really leaves us with one final question to think about for your own setup. Is your network a frustrating bottleneck, or is it a seamless digital superhighway? Because the right hardware doesn't just support what you're doing, it completely transforms it.